Hello, welcome back to 9th class social studies. So we discussed already about lithosphere and hydrosphere. In this module, in today's module, we are discussing about atmosphere. Atmosphere can be defined as a sea of gas surrounding Earth. So a lot of gases are there part of atmosphere. And all the identified gases, lion's share around 78% of atmosphere is occupied with nitrogen, and 21% of atmosphere is occupied with oxygen, and all other different gases altogether accounts for just 1%. And out of that 1%, other than the nitrogen 78 and oxygen 21, one of the major component is water vapor. Water vapor accounts for around 0.4%. Sure, water vapor is the gaseous form of water. And the presence of water vapor is limited up to around 6 kilometers. So that is the place where we can see all the weather phenomena that we will see later in the coming explanations. So the atmosphere, as I already explained or as I already defined, is a sea of gas surrounding Earth. Or we can say atmosphere is a thin blanket covered around the Earth. It's around 1000 kilometers in thickness. As per the information given by National Aeronautics and Space Administration, NASA, as per their information, if we compare the entire Earth as the size of a basketball, the atmosphere is nothing but a thin plastic sheet that covers around that basketball. Only that much. So the size of a basketball is compared with the size of the Earth, and the atmosphere is compared with the thin plastic. Very thin plastic paper will be wrapped around that basketball. So only that much. But even that thin layer of gases, that is very important for the existence of life and for all the different weather changes or the weather phenomena. So that is what we are going to discuss. Okay, so we have already seen that 78% of atmosphere is occupied by nitrogen, the single largest gas, and next comes oxygen with 21%. And all the other identified gases altogether occupies just 1%. And out of that, water vapor accounts for 0.4%. And that is visible or that is present only up to a height of 6 kilometers. That's important. Then another important ingredient or another important part of atmosphere, what we can see is fine dust particles. The dust particles are contributed to the atmosphere through the natural process, sand dunes and other sandstorms, then by the human and animal interventions. When we are burning the things, when we are digging the land for constructions and all, the dust particles are contributed to the atmosphere. And the dust particle present in the atmosphere is called by a special name, that is what is called the particulates. What? Particulates. And this particulates affects atmospheric conditions. It affects atmospheric conditions. It just shows or it just makes us to see the beauty of sunrise and sunsets. And the beautiful rains, the temperature is getting affected. And it just affects certain problems for the human beings and animals and plants, living organisms. The excess amount of particulates in the atmosphere makes us to breathe uneasy. the breathing problems for the human beings and animals, and the excess amount of dust particles, it will start rusting on the leaves of the plants, eventually dying, or eventually leads to the death of that plant. So that's all about the atmosphere. And atmosphere, as it is already defined as a gas surrounding the earth, it just shows all the properties of gas. The atmosphere compresses, it expands, and it has no shape. The normal specialities or the normal features of gas: expands, then compresses, and it has no shape. Then about the structure of atmosphere, as we learned about the structure of the earth, the atmosphere also has got a structure. We are trying to identify or try to learn the structure of the atmosphere. It is divided into various layers, and the layer by classification is very difficult. Identifying the layers of the atmosphere is very much difficult. And the scientists are doing all these activities through sending air balloons and with the help of satellites and all. And as per all these efforts, through the chemical composition, as per the chemical compositions, the entire atmosphere is divided into two layers: homosphere and heterosphere. Homosphere, which extends up to a height of 90 kilometers, is further divided into three: troposphere, stratosphere, and mesosphere. These three layers altogether are called as homosphere. It is called as homosphere as there is a uniformity in the composition of gas in these three layers. And from 90 above, the kilometer from 90 above, it is grouped into another layer which is called as heterosphere. And the heterosphere is subdivided into two more layers. They are thermosphere and exosphere. And this layer is called as heterosphere as the gaseous composition in this layer is heterogeneous in nature. So that is the general division or the general structure of the atmosphere: homosphere and heterosphere. As I said, homosphere is divided into three and heterosphere is divided into two. So altogether we can have a 5 more subdivisions. We shall see each and every 5 subdivisions: troposphere, stratosphere, mesosphere, thermosphere, and exosphere. Thermosphere is also called as ionosphere. Okay, let us start with the troposphere. The first or the lowermost layer of the atmosphere is troposphere, and the average height of the troposphere is 13 kilometers. It is in between 8 kilometers to 18 kilometers. Okay, in the polar region it is 8 kilometers, and in the equatorial region 18 kilometers. We have already seen that atmosphere shows all the properties of gas. It compresses, expands. When the temperature increases, it expands, and the temperature is automatically high at equator. So it extends up to 18 kilometers, and the temperature is low to the polar region. So it compresses up to 8 kilometers. Or on average basis, 13 kilometers is the average height of troposphere is 13 kilometers. Then another important thing: 75% of all the gases mass is present in this particular sphere, troposphere, and the maximum particulates are available. So remember that water vapor, the presence of water vapor, it is available only up to around 6 kilometers. We have already seen that 0.4% of water vapor is also present in atmosphere, and that can be seen up to a height of 6 kilometers, and that is part of weather phenomena. Okay, it has got a part of weather phenomena. All the weather phenomena, all the parts or all the things related to the weather conditions, are present in troposphere. Condensation takes place in this particular sphere, evaporation takes place in this particular sphere, and the precipitation happens to be in this particular sphere. So troposphere is very important. All the weather conditions are happening in the lowermost layer of the atmosphere, which extends up to the height of 18 kilometers to the equator. Average height of 13 kilometers. Okay, and here about the temperature. Normally the temperature increases, whereas in this troposphere the temperature decreases with the height. As we are going higher, the temperature decreases. So a normal lapse rate of 6 degrees Celsius for every 1000 meters of ascent. For every 1000 meters. For 1 kilometer in height, 6 degrees Celsius of temperature is getting reduced, and that is what is called the normal lapse rate. And that is one of the major speciality of troposphere, where the temperature reduces as we are going higher. That's all about the troposphere. The lowermost layer, 13 kilometers in average, 8 to 18, 8 kilometers near the poles and 18 kilometers to the equator. And all the weather conditions are happening here. And the temperature decreases with the height, which is called as normal lapse rate. And the second one is stratosphere. It extends up to 50 kilometers. Where the troposphere ends, there starts the stratosphere up to a height of 50 kilometers. And it is free from the clouds and all the weather phenomena. Nothing. It is as clear as anything, no clouds, no nothing, no phenomena related to weather. So this particular sphere is very ideal for flying flights. Airplanes are flying in this particular layer, the second layer, stratosphere, up to around 50 kilometers. And another specialty of stratosphere, this is the area where we can find the ozone layer. Okay, you know about ozone layer, which is very important in protecting us from the harmful ultraviolet rays from the sun. So ozone layer is part of stratosphere. And here about the temperature increases with the height. Remember, temperature increases with the height in stratosphere. In the first layer, troposphere, the temperature decreases as we are going up. Whereas in stratosphere, the temperature increases with the height. Okay, so up to 50 kilometers. No clouds, no weather phenomena. Ideal for flying flights. And ozone layer is present. And the temperature increases with the height. And the third one, mesosphere, up to 80 kilometers or 90 kilometers. Okay, this is the layer, or this is the last layer, part of homosphere. 3 layers are there in the homosphere: troposphere, stratosphere and mesosphere. So mesosphere up to 80 to 90 kilometers. And the speciality of this particular layer is meteorites. It just burns up in this air. That breakaway particles which comes to the earth, which is being under the gravitational pull of the earth, it is getting burns up in this layer. Meteorites are burning up in this layer of mesosphere. And here the temperature starts decreasing with the height again. See, the first troposphere, the temperature decreased. Second, stratosphere, temperature increased. And the third, mesosphere, the temperature decreasing with the height. So the first 3 layers, part of homosphere. And the next 2, thermosphere and exosphere, as part of heterosphere. Thermosphere extends up to 400 kilometers. Where the mesosphere ends, there starts the thermosphere. And it extends up to 400 kilometers. And this particular sphere contains electrically charged ions. As this area is marked with the presence of electrically charged ions, this sphere is also called as ionosphere. Thermosphere is also called as ionosphere because this layer contains electrically charged ions. And this is the layer that reflects the radioactive waves from the earth. We are sending the radioactive waves, and those waves are being sent back to earth through reflection by thermosphere. And about the temperature, rapidly increases with the height. Temperature rapidly increases with the height in a thermosphere. Thermosphere is also called as ionosphere. And the last, that is exosphere, the last layer. It is the uppermost layer, more than 400 kilometers. So, as naturally we can expect that we don't know much about that layer. We are assuming that there is a layer called the exosphere, only that much. The scientists are blank about the chemical composition of exosphere. So, the only given explanation what we can give is that this is the uppermost layer. So, that's all about the layers of the atmosphere or the structure of atmosphere. The entire atmospheric area can be divided mainly into two based on the chemical composition, homosphere and heterosphere. Homosphere is further divided into troposphere. Into three, as troposphere, stratosphere and mesosphere. In troposphere the temperature decreases with the height, and in stratosphere temperature increases with the height, and mesosphere once again it decreases with the height. And from the thermosphere the temperature starts rapidly increasing with the height, and exosphere also we are expecting the temperature will be increasing. That's all about the atmosphere and the layers or the structure of the atmosphere. Then about the pressure belt, winds and all we will discuss in the next module. Okay, thank you.